In this video, we are going to look at factoring by grouping, factoring by the sum and difference of cubes, and factoring with quadratic form. And I hope you like my self-portrait. All right, first we're going to start with factoring the sum and difference of cubes. And honestly, the best way to start with this is to actually write out all the cubes, because there's a limited number of them, and you'll begin to recognize them if you know what they are. So I've started you over here writing the cubes, and I want you to write these in your composition notebook. You may have to stop the video, copy them down, and write them. I'm not going to do all of them. I'll do a few. 1 to the third is 1. 2 to the third would be 2 times 2 times 2, which is 8. 3 to the third is going to be 3 times 3 times 3, which is 27. 4 to the third will be 4 times 4, which is 16, times 4, which is 64. 5 to the third, do 6 to the third, 7 to the third, 8, 9, and 10. Okay, go ahead and finish the cubes in your composition notebook. Don't skip this step, please. Okay, you can stop the video and then tune back in. Okay, so when you get ready to do the sum of two cubes, there is a pattern. All right, so I'm going to write this just a little differently. I'm going to say x to the third plus y to the third, and do it that way. All right, now here's the pattern. You have parentheses here and parentheses here, longer ones. All right, this sign is the same sign. This sign here, this is the same. This sign is the opposite sign. And then this third sign here is always positive. So sometimes you'll see it, they'll say it's soap, because it's same, opposite, and then always positive. All right? Then the first one is just going to be x and y, whatever was inside the parentheses, x and y. Okay, this number right here is going to be x squared, or this first number here squared. This here is going to be this one squared, so y squared. And then the middle number is just going to be x times y. And so once you learn this pattern, you have to do quite a few of these to learn the pattern, but that's how you do it. So we're going to do the same thing with the difference of two cubes. Okay, so I have the parentheses, just the same. The first is always the same, right? So that's the same. The next sign is opposite, and the last one's always positive. Same, opposite, always positive. So I have x, y. The first term is x squared, the last term is y squared, and the middle is those two multiplied together. So once you get the signs in, you really don't have to go in and you don't take into consideration that that's a minus. You write the signs in first, and then you do the pattern for the other. All right, so here is an example hiding down here at the bottom. Okay, so I'm going to rewrite this. I have u to the third plus something to the third. Well, I notice up here that 8 is 2 to the third. All right, so when I go to write this, first I put in my parentheses, then I do, this is the same sign, plus, this is the opposite sign, minus, and this is always plus. And then when I put here, I put a u and a 2. I put what's inside the parentheses. Okay, this first one right here would be u squared. This last one down here would be 2 squared. And then the middle term would just be 2 times u. And that's how you factor the difference of two cubes. Okay, so once again, I have written on here, you have same sign. This is same. This is opposite. And this one is always positive. All right, so if I'm doing this one, this is the sum of two cubes. So I've got x to the third plus, and remember from your cubes that 27 is 3 to the third power. So you write your parentheses. The first is positive, right? The next sign is negative. This one's always positive. So this first thing is always the x and the 3, x plus 3. Then this is the first term squared. This is the last term squared. And then this is 3x. All right? So this never factors. In fact, its roots are not real. But it will never factor. Okay? So then if we do this one, this other example, the first thing you want to do is write it as cubes. Okay? So this would be 2x cubed, 2x quantity cubed, and then this would be 5 to the third. All right? So this first is a minus, it's the same sign. Opposite sign, always positive. Write it in, 2x and 5. This first term is 4x squared. The last term is 25. The middle term is found by multiplying those together, 10x. And you're done. Another technique that we can use here is called factoring by grouping. And I will just tell you, this doesn't always work. You need to have 4 terms. Not all polynomials have 4 terms. Generally, it's to the third. The highest term is to the third power. And so these, I believe, will work, but sometimes they don't. So if you put these in order, like this, in groups, okay? And in this group, the first group, I'm going to change colors on this group, right? In the red group, you can factor out a p squared, right? So I have 2p plus 5, okay? In the blue group here, I can factor out a 3, and that's pretty much it. So plus 3, and when I do that, I end up with 2p plus 5. All right, so I've gone from 4 terms down to 2 terms. All right, so what can I factor out of both of those terms, the black terms? Well, I can factor out a 2p plus 5 from each term. All right, so when I do that, I have p squared plus 3 left, and that factors by grouping. Okay, I can do the same thing here. I have these 2 terms, and then I have these 2 terms. All right, so in the red, I can factor out a 4 and an n squared. That leaves me 4 times 3 is 12, 3n, and then plus, and since 4n squared times 1 gets me 4n squared, that factors out. All right, so then I look at this other one, and it just says 3n plus 1, nothing to factor out. If factoring by grouping works, then these 2 terms are going to be the same. If it doesn't work, they won't. So in order then, I have this group and this group. I can factor out a 3n plus 1 out of both groups, and I'm left with 4n squared plus, remember that that's a 1, 1. One final technique is factoring trinomials in quadratic form. So instead of it being, we factored things that were like x squared plus 2x plus 1, right? That's quadratic form. Well, you can see that they're kind of like quadratic form. They're x to the 4th x squared. But if you look at this first one here, there's just 2 terms. And so it is not going to factor like that, because it just has 2 terms, but it has something in common, which is u squared. So you're going to factor out a u squared, and so it's really just finding a common factor, this one. So it's not always going to be in that form. Now this one will be, though. All right. So what we're doing is we are going to factor it just like we would a regular quadratic. Okay? So, but instead of doing x and x here, like we would do for a quadratic, we would do x squared and x squared. And then you ask yourself, what are the factors of 12 that subtract to get 1? Well, that's going to be 4 and 3. And since this is negative, it's going to be opposite signs. So this is going to be plus, and that's going to be minus. And that's factored. That's what it looks like. So instead of those being x's, they'll be x squared. But you're using the same techniques that you would be to factor a quadratic to factor these. All right, so for instance, when you're doing this one, you would have another way to think of this, and I'm not sure if this will help or not, but another way to think of this is to write it like this. Let's say that, let's let u equal x squared, right? So if we rewrote this, we would have x squared squared minus 8x squared plus 15. So if we let u equal x squared, this would be u squared minus 8u plus 15. Well, now this is quadratic form. Okay, so we would just graph it like this. We would say u and u. What are the factors of 15 that add to 8? That would be 3 and 5, both negative. And then what was u? Well, u, oh, it's not letting me write. U is x squared. X squared. And so we replace the u back with this. So this is in essence what you're doing. We're just graphing something that, or we're just factoring something that looks like that, but it's something that's in quadratic form, but isn't actually quadratic in nature. So, okay, what would you do with something like this? This looks really awful, doesn't it? Well, let's think about it this way. Like this. And then, just like what we did on the previous one, let's let u equal x to the n and rewrite it. U squared plus 9u minus 10. Okay, that looks like something that we're used to seeing, right? So let's factor it. This is quadratic form. So I have u and u. Factors of 10 that subtract to get 9 are 10 and 1. So this will be plus and this will be minus. Okay, substitute back in. So I have x to the n plus 10, x to the n power minus 1, and that's it. So this is still quadratic form. Okay, this is a lot of information. We're going to be practicing this a lot in class. Be sure that you take really good notes, and I will see you in class.